Hi guys, I'm Chris Wynn-Jones and this is ReliaCast. This is episode 8 and we are going to be talking about product lifecycle. But before I go into product lifecycle, I just need to cover the applications that we've been talking about in the previous videos. And these applications come from the ReliaSoft toolbox, and this toolbox is all the different tools that are available for doing various different analyses. And we've talked about Wible++, we've talked about RCM++, we've talked about Alter, XFMEA quite a lot in some of the videos. So if you want to know more about these applications and what the analysis is for those, how you use them, then you can go back to the previous videos and look at those for the various topics that you might want to cover. And for this video, we're talking about product lifecycle, and the product lifecycle covers all of these tools at some point. So as we go through that product lifecycle, I'm going to mention a few of these tools, and we're going in and out of those tools to do the various different things. But I'm keeping the product lifecycle presentation discussion today at a very high level. So today's video is aimed at new engineers, it's aimed at people who are new into reliability engineering in particular, and it is aimed at people who want to know a little bit more about other tools and how they fit outside of their little bubble, because there is a lot out there in the industry, a lot of situations where there's a silo effect, where you are sat as, say, a design engineer, and you don't necessarily understand as a design engineer what is going on further down the chain from the little job that you're doing and what the impact is on that. So you end up with these silo teams, and what we're trying to do with the product lifecycle is to remove those silos with a reliability process that is connecting everything together through that product lifecycle using these tools. Okay, so I'm just going to move on to the next slide, and that should come up here about now. Right, there we go. So here it is, the product lifecycle. So we're starting at concept on this side, going right away through design, through development, through manufacturing, and into support. And the different applications that you're going to be using during that life cycle is down at the concept stage. We're going to be looking at the product in a very it's the engineering end, where all of the paperwork is being done for the concept. So you're coming up with the drawings, you're coming up with the stress analysis, you're coming up with the interfaces between the different components, you're coming up with what components you're going to need to use. So you might be using tools like Lambda Predict to work out parts lists of components that you're going to put onto PCBs that are going to go into this concept to make the concept work. And the structures, doing your materials analysis using various different tools for that. So if you want to look more into the physics of failure aspect, then we'll be looking into a combination of the ReliaSoft suite and the ReliaSoft bits that we're using in our reliability world and reliability bubble, looking out towards understanding the physics of failure. And the physics of failure, a lot of the information for that is coming from the ENCODE products, which we also do. So if you want to do a little search on ENCODE, feel free, go ahead, and certainly going to help you out with that side of things on what we know as the durability side of things. From a reliability point of view, we want to know what that physics of failure is, how are things going to fail, and then that information, knowing how things are going to fail as a reliability engineer, we're then putting that into a DFMEA. And the DFMEA is lines up with the design phase here, and within that design phase, the DFMEA, we're looking at the failure modes, the failure effects, the causes, and then working out some controls and actions which are going to need to be put into place to be able to detect that failure mechanism. That then links us into thinking about doing a test design. And the test design for reliability perspective is then passed on to the development team in the development testing down this end. So once that is then down the development testing, along with all the other requirements that have been raised by stress analysis, been raised by warranty information from the warranty returns from the other end of the process, all that information then gets fed in and then justifies the need to do various aspects when it comes to testing to then prove out whether that scenario could actually happen. Then after development and testing, we're then looking at manufacturing. So we're going into the process, and in the reliability world, we're thinking about process FMEA. So the process FMEA is then coming in, and that is the PFMEA. And I've got a little bit more detail in the next slot, talking more about these different engineering aspects that are in this. That then after manufacturing goes into support, and that's where our warranty information is going, and our maintainability. So the maintainability is a huge aspect down this end, and understanding where things need to be maintained to keep the availability up. So we've got the reliability as we go through, the availability and the maintainability, all these different aspects being looked at for RAM engineering. And then above all of that is considering impacts on safety, in and out of the safety as we go along. So all things I'm talking about here, and the RCM analysis down at the maintainability side in the maintenance, all of these have been spoken about in more detail in other videos prior to this. So that's the process. I'm going to go into more detail in the next video. Quick change, next video, let's run that. Okay, so the next one, a little bit more detail now on that product life cycle. So just some idea of some of the tools that are in place. I appreciate it's on the board behind me now. And so we've got the different tools that go through that life cycle. So I'm just going to pick on a few of them. I'm not going to talk about them all. So we've got all the requirement gathering and the information we're going to gather as you go through the process. And then the design FMEA. So the DFMEA, analysing all of the risks and the things that might go wrong in the product as it's going through its service, what we know and the things we don't know that get fed back through the process as we learn, they get added to the DFMEA. Then moving on up then to the risk and the safety, so the things that we get covered and captured there, fault tree analysis, that sort of thing. The data that we get back from the failure measure and liability analysis. So we're collecting the wireable analysis that we do for failures versus failures and suspensions over time, and then we can work out a distribution over time, so that goes into there. Then we've got the baseline reliability, building that up. So we're going into the wireable tool. So we've done XFMEA, we've done wireable++, and I'll just shift my head over this side. FRACAS, failure reporting and corrective attitude system. So this is useful when it comes in at the development stage, because a lot of people see this as a service tool, whereas the FRACAS tool is actually useful in the testing environment as well, internally. So when things fail internally, you can collect that data. So when these things fail, and we can use this FRACAS tool as part of our lessons learned feedback process. And what FRACAS does is it feeds back to the DFMEA and other tools up here with the wireable analysis, and it feeds that information back into the process when you're using our XFRACAS tool. Within the XFRACAS tool, you've got lots and lots of control options used following the 8D process. It can be other amounts. If you're familiar with the FRACAS, there's different amounts of steps that you go through, and they're disciplines. So the 8 disciplines is kind of the biggest one, and they can be a 7 or a 5, depending on what FRACAS process you're used to using, and that gets all set up within the tools. And then just moving on, then we've then got the testing, collecting all the data at these various steps, doing some reliability growth analysis, so back in the wireable++ tool, and then while we're doing all this, we're producing the reliability block diagrams. These reliability block diagrams take the models from the wireable analysis, and you can set out your system in blocks and see which one's most likely to fail. And this helps again with identifying some of the tests that need doing, just to see how long things are going to live and within the system. And then we get on to the PFMEA. Now this is where I wanted to get to with this. The PFMEA in this diagram is right down here in manufacturing, and the PFMEA part, this is process failure modes and effects analysis. So design failure modes and effects analysis on this side, and then the process one's down here. So we're going into the manufacturing, and what we should be doing is a not preliminary, but sort of a concept process failure modes and effects analysis back with the design at this end. So back here with the design from here, we finish the design from here, and then we start thinking about how the process is going to happen. Similar to the concept and design stage here, we're doing a concept and design around about here in the timeline. We're doing a concept and design, and then before we get to completion over here for manufacturing, we've already been through the loops of the PFMEA concept and design of the PFMEA. So we're doing the concept PFMEA, we're doing the concept manufacturing process, and we're putting that down and we're documenting that. We're working on that before we get to this PFMEA here. Okay, so once we've done that, we've then got field data for collecting and warranty analysis and things like that, which we can then go back to doing in the Wireable++ tool. So bringing these all together, it's also, I missed maintainability, the maintenance plan. Yes, so we're using the BlockSim tool, the BlockSim tool for the maintenance plan. Now what you can do with all this is all the data that you've collected so far, you can convert, for example, the DFMEA, you can use that to start your reliability sensitive maintenance analysis. And reliability sensitive maintenance is our RCM++ tool. And what that allows us to do is to do an analysis very similar to a DFMEA, but instead of controls and actions, which is what comes out of a FMEA, instead of controls and actions, we're looking at the time to failure model for what we call the reliability policy, and the tasks that are needed to maintain that product, to either bring that product back online when it fails, or to keep that product going without it failing. This is where we bring in one of our tools, optimum replacement. Optimum replacement helps us to work out when we're going to optimize a replacement before it fails. So you're doing all of your times for your servicing and things like that of your particular product out in service, and we can do all this analysis to help the customer while they're using the product out in service. And we say to them, well, you need to replace this item every 1,000 hours or every 1,000 miles or every 1,000 kilometers, whatever language it needs to be in. And the replacement time is determined based on the product knowledge, on our knowledge of the failure model in which it's going to fail over time. And we only know that failure model and that distribution over time. We only know what that is because we've done our testing, or because we've done collecting data from our fracas from in service or fracas from testing, and we know when those failures are versus the amount of items that are out there that have survived. And we can then pull those together, we can build a failure distribution, and then from that failure distribution predict when something is going to fail and exactly what time it is predicted to fail. And there's a level of confidence as well involved in that, which we've talked about in previous videos. Alright guys, this concludes video for product lifecycle. And if you want to know any of the different bits that I've been talking about in the video in more detail on reliability, availability, maintainability, and a little bit on safety for the fault tree analysis, then watch the previous videos, and there's a lot more detail on those, as well as the guests that I've been bringing in to talk about those topics. It's really interesting. If you like what you've been watching, please let me know by liking, thumbs up, subscribe as well, and please drop me some comments in the comments at the bottom. I'd love to get some feedback, because this is now our last video of series 1. Thank you very much. Thanks for watching, and I'll see you all soon.